Welcome to today's keynote. For the past few years, we've been working on a new generation, rebuilding everything from the ground up. This is our biggest leap yet, and our biggest set of changes ever. We call it Starlight X, SLX for short. So let's start by looking at the new shape.
This is our first new shape in 11 years. The original Final Mouse shape went on to become one of the most iconic and copied shapes in gaming. It helped define what a great mouse shape could be. So we know how hard it is to get right. For the last 4 years, we've been working on a new one. Hundreds of iterations, starting in clay, then over 50 full prototypes. Every curve, every surface, refined over and over again, because making a great shape isn't about guessing, it's about understanding how people actually aim. Shapes exist on a spectrum. On the one hand, you have a pen. It uses the most precise interface the human hand has, the thumb and index finger. That's why in games like Osu, players use tablets. It maps directly to how we write. But as movement changes, that breaks down. In games with a balance of vertical and horizontal tracking, like Apex or Overwatch, you need more stability. And in tactical FPS, like Counter-Strike, where most of the movement is horizontal, stability becomes even more critical. You need to filter movement, make it repeatable. That's where shape matters most. With our previous designs, we adjusted size over time to match the games people were playing. This time, we focused on one goal, a shape built for modern tactical FPS, a shape built for games like Counter-Strike. More stability, more support, a fuller hump, better contact while keeping the precision. Narrower width, defined click grooves, so you still have control where it matters. It's designed to feel stable but not restrictive, precise but not sharp. We took what worked from the original shape and rebuilt it with better geometry, smoother transitions, better ergonomics, no pressure points. The goal is simple. When it's in your hand, nothing stands out. Nothing distracts you, it just fits. And when it does, you stop thinking about it.
With ULX, we pushed click latency forward. We were among the first to break the sub 400 microseconds in end-to-end click latency. And we built XLAT to measure it properly. A system that captures true end-to-end latency, from electrical actuation to USB. Even today, ULX remains one of the most responsive mice ever measured in third-party testing. But we weren't satisfied, because that measurement only starts at electrical actuation. When you click, there's a physical delay. Your finger begins to move, the switch pre-travels. The metal leaf compresses and snaps. Only then does the electrical signal begin. That physical latency is the slowest part of the entire chain, and it was completely unaddressed. So we built a new system, TMR-DS, which stands for our TMR Dual State Analog Click System. And we built it without compromise. No added weight you can feel. No penalty to power consumption. Just 0.24 grams for the entire system. Instead of waiting for the switch, TMR-DS reads the moment your finger commits to the click. There's a magnet embedded in a sleeve under the clicker, and a high-precision TMR sensor placed on the PCB. As your finger begins its downward motion, we detect a change in magnetic flux immediately. In total, SLX reduces click latency by up to 35 milliseconds compared to other mice. This is the fastest click system in the world. TMR sensing is also the most advanced analog sensing method available, more precise than Hall effect, more precise than induction sensing, and more power efficient. Because the TMR system is external to the switch, we're not constrained by the footprint of a switch-integrated IC. That means we can use the best-in-class TMR sensors, placed independently on the PCB, just north of the switches. This lets us optimize the geometry completely. The distance between the magnet and the sensor, the alignment, the sensing range. We tuned the system to operate in the most optimal ADC window. Maximum sensitivity, zero noise. That's how we achieve actuation control in increments as small as 0.01 millimeters. 40 discrete steps, just within the pre-travel window. To put that into perspective, 0.01 millimeters is 1/10 of the thickness of a human hair. So you're not just clicking faster, you're controlling exactly when the click happens. But speed alone isn't enough. It has to feel right. So we didn't replace the switch, we kept it. In SLX, we use a 1.0 blue shell pink dot switch, one of the best mechanical switches available. Crisp, tactile, consistent. Because the best click feel still comes from a purely mechanical switch. So instead of compromising the feel to chase performance, we engineered around it. Two systems working together. The mechanical switch delivers the tactile response. The TMR system reads the intent and delivers the speed. Because they're separate, we can optimize each one independently. No compromises to feel, no compromises to performance. And in Xpanel, you can choose mechanical mode or analog mode. But what you notice is how it all comes together. The moment you decide to click, everything follows. The click and the shot line up. It feels immediate. Like your input and the result are the same event. And in a fight, that matters. Two players see the same moment, the same angle, same reaction. But one shot leaves first, 35 milliseconds earlier. That's not a small difference. That's the equivalent of adding coast-to-coast network delay to the other player. That's the difference between playing on a local server and playing across the country. That kind of gap decides fights. With TMR DS, you're ahead, before the fight even starts.
We've always pushed lightweighting forward. From the beginning, we were the first to apply lightweight engineering to gaming mice. Then we moved into new materials: magnesium, carbon fiber composites. Every generation, from the Ultralight Pro to the Air 58 to the Starlight 12 to ULX, we kept pushing the limits. With SLX, we changed the chassis completely. This is our biggest mechanical redesign to date. The internal geometry has been rebuilt from the ground up. A completely new structure. No more honeycomb shell. Instead, we developed a new internal architecture focused on structural efficiency. The entire construction has been simplified, from a 4-part assembly to a new unibody main cage, reducing the primary shell to 3 components. The assembly itself follows a different philosophy. Inspired by Formula One, we use graphite-coated titanium screws throughout the chassis, 15 in total. This is a shift from traditional lightweight designs that rely on snap features. Each screw weighs just 0.02 grams, so we're able to increase structural integrity without compromising weight. The result is a construction that is fully locked in. No flex, no creaking, no gaps, a more solid, consistent feel in hand. We also rethought how weight reduction is achieved. Previous designs relied heavily on honeycombing. It worked, but it came with trade-offs. With SLX, we moved to a new approach: strategic carbon fiber beaming with thinner nominal wall sections. This achieves lower weight without relying on large open patterns across the shell. With the new shape providing more palm contact, it was important to remove any tactile distraction. Using pressure mapping, we identified areas of the mouse that are never touched during gameplay. Those are the only places we open the chassis, optimizing weight without affecting the surface your hand interacts with. We also redesigned the click mechanism. With TMRDS, stability becomes critical. Any wobble affects sensing. So we developed a new guiding system inspired by mechanical keyboard switches. A dual rail system with PTFE guides that constrains the plunger on both sides, eliminating lateral movement, eliminating grinding. The result is the most stable click system we've ever built, and the smoothest. Finally, we pushed the materials further. For SLX, we worked with aerospace vendors to develop a new carbon fiber composite, a material with a density below 0.9 grams per cubic centimeter, lower than water. It contains 70% more carbon fiber than our previous composite and is significantly stiffer. That gives it a strength to weight ratio over 3 times greater than magnesium. Combined with the new internal architecture, this material creates a structure that is both lighter and more rigid in critical areas. So the result is something new: our lowest density mouse ever, and our strongest. It's something you notice immediately when you pick it up. Lightweight and solid at the same time.
With ULX, we pushed wireless performance forward. We were the first to deliver true unbuffered 8K wireless, a system built on advanced RF architecture with dynamic channel hopping. We also introduced SubTick, a system that allowed click data to bypass traditional polling limitations, enabling sub 400 microsecond latency across all polling rates. And we did all of this with industry-leading power efficiency. So for SLX, we knew the next step wouldn't be easy. We didn't want to chase specs, we wanted real improvements. That meant starting at the foundation. We went directly with our silicon partners to access hardware that didn't exist yet. At the center of SLX is a new MCU, the Nordic NRF54 LM20. We were among the first to receive early samples from Nordic, and it was immediately clear this was the platform we had been waiting for. It moves from a 55 nanometer process to an advanced 25 nanometer node. That unlocks improvements across the board: better power efficiency, higher transmit performance, more processing speed, and support for 4 megabit RF modulation. For the first time, we're able to use an MCU with high-speed USB in both the mouse and the receiver, eliminating the need for a high-speed bridge in the dongle, which reduces latency across the entire system. It also allows something we wanted for a long time: true synchronization, from sensor polling all the way to USB output. In previous systems, features like motion sync were used to smooth data, but they added delay. With SLX, we removed that entirely and replaced it with a new system: Perfect Sync, an always-on architecture that keeps the entire signal chain aligned. No smoothing filters, No added latency, just synchronized data from sensor poles to USB. At the same time, we rethought polling rates. For years, polling rate has turned into a spec race. 2K, 4K, 8K, a marketing gimmick similar to what DPI had become in the past. But in reality, higher polling rates don't always improve performance. They can reduce RF robustness, increase system load, and negatively impact battery life. And in competitive play, they're often avoided entirely, because they introduce more problems than they solve. With Subtic, we had already moved beyond that model. So with SLX, we took it further. We built a single system designed to be optimal. Perfect polling. It combines Subtic latency optimization with efficient RF polling windows and high-speed USB interrupts on the receiver. So you get the benefits of high-speed performance without the drawbacks. No settings, no confusion, it just works. Best-in-class latency, strong RF performance, better battery life. At the same time, we upgraded the sensor. Working directly with PixArt, we went beyond their current generation. Not just one generation ahead, not two, three. We developed a custom sensor, the Final Mouse F1, built exclusively for SLX. It delivers higher resolution accuracy than anything before, and improved efficiency at the same time. And just having the latest generation sensor isn't enough. It's about implementing it optimally and testing it thoroughly, because the sensor code and the firmware is equally as important as the chip itself. Finally, we optimized the RF system itself. On the receiver side, we redesigned the dongle, a compact puck form factor with a thicker profile to support a raised metal antenna, improving radiation efficiency. We also added a steel weight inside the dongle to ground the PCB and keep it stable on the desk. On the mouse side, we repositioned the antenna, moving it north on the PCB and switching to a ceramic chip antenna. All of this contributes to overall system efficiency and gives the SLX the longest lasting battery life of any wireless esports mouse. A system designed to perform without interruption. Everything working together. Latency, synchronization, signal strength, power efficiency. No wasted features, no unnecessary complexity. Just a wireless system built to perform at the highest level. What we've shown today is just the beginning. We could keep going. There's more to every system, more to every detail. But at some point, you need to see it. So, without further ado, here's the Starlight X SLX.